Alright. Um, I took my TLO 72 and rigged it up as a summer, so, summing amplifier, and it's not really amplifying anything. Well, it sort of is, in the sense that it's a summer, but, I got like 10K resistors, on, you know, for the feedback resistor and the two summing resistors, and, I've got, um, the one of the waveform from analog discovery inputs going in here and the other one going in here, so they're summing together in that junction there, and the output's coming out, and I've got it fed into an audio amplifier that I got set up there with a little speaker back there, which I don't know if you can hear it through this microphone, but and here in the analog discovery, here's the waveform output of the two signals. Now the two signals, one of them's 25 kilohertz, and the other is like 30 kilohertz. So, but if I turn it up here, I mean it's kind of feeble. I still don't know if you can really hear it. It's kind of a 5 kilohertz tone, something in that neck of the woods. I don't think this amplifier reacts too well, to these higher frequency components going in there. I have a feeling they have an attenuator to filter out higher frequency components, so I think it's reacting negatively to that. I tried building a first order filter there, but that's not really doing much good. But if I had a laboratory filter, well, that would be awesome, right? It's one of the reasons I want to build a laboratory filter for things like this. Then I could probably filter this out, like even fourth order filter. I could set its corner frequency like 10 kilohertz and, knock it down to well below, um, 10%, or, 10%, at 25 kilohertz. But, and that may improve things a bit, so I can get that beat frequency out of it. But see, if I turn, one of these off, you can't hear anything anymore, because it's just the raw frequency now, and they're inaudible. To me, they are, but I turn them both on, you get that, um, nice little beat wave there, that little envelope it generates. So, at any rate, this is kind of a principle they sort of use in like some metal detectors. In fact, I saw this guy on YouTube named Great Scott, build one of these, and using an OpAmp to sum the frequency components of it, and I was like, man, you sure gone crazy. I mean, these metal detectors use nonlinear mixing, to produce those sum and difference products, and that's kind of the whole idea. But technically, I got to thinking about it. I was like, I mean, it might work because, I mean, in theory, yeah, you can add two different frequency sine waves, and you'll produce, you know, like a beat pattern, right? So, and that beat pattern, in fact, could be audible because it's, indeed producing a much lower frequency than the, you know, two input frequencies apart um, will produce. So, um, but you go down to see if I can go to 31. See, 31 kilohertz. Again, it's hard to hear it, but it's producing about a 1 kilohertz frequency. So, but I'm sure you can't hear that. I mean, I almost got this thing maxed out. Yeah, it is maxed out. So, but it is audible. So, anyway, so yeah, the theory does work, and this thing does mix like it should. Being an op-amp mixer. So, at any rate, but yeah, his Great Scott's little metal detector didn't sound too good, so I wasn't sure wasn't something else in his circuit, because it wasn't a clear tone I would have expected. But I don't know. Maybe his was having some similar issues or something. I don't know. Anyway, just thought I would, you know, show you that. So, cheers.